All right, hi everybody. Today we're gonna go through a mountain climber question. So a mountain climber pauses for a rest while in the process of crossing between two cliffs. Sally is the climber. Weight of 535 newtons. She's closer to the left cliff than to the right, resulting in the two tensions to not be the same. Find the tension. So drawing. Here's a little Sally. 65-degree angle on the left. 80-degree angle on the right. As you can see, my clips are a little off, but we'll go with it. So, first and foremost, for all these design process, remember, we draw our free body diagram. So I have like my little box for Sally set up. So we have weight going straight down. We have our two tensions then as well. I'll label the one on the left T1, the one on the right T2. Okay, now, due to the fact that these are at an angle, okay, I'm going to redraw these with their right triangles. So notice my angle is at the 65 degrees right there. So that makes my triangle something like this. So that's a 65. That's my T1. So that's my T1X, my T1Y. And then same thing over here for the one at 80. T2, T2X, T2Y. Okay, so free body diagram's done, and then drawing my two force vectors as well off to the side to make life a little easy for myself. Like I said, you could easily draw these T1Ys and X's on here, but I just don't, to help myself kind of save some space and make it a little less clutter. Okay, so step 2, summation of my forces in the X and summation of forces in the Y. Both acceleration 0 because we're not moving. So for summation of force to the x, I have t2x minus t1x equals 0. And for the y, I have t1y plus t2y minus weight equals 0. And yes, we can plug the weight in a second, which is not going to. So my overall goal is to get to T1 and T2. And right now I have the subscripts T2x and T1x, T1y, T2y. Okay, so I need to rewrite these using my sine and cosine. So looking at my right triangle, my x values are my opposites in both of these, which means T2x becomes T2 sine of 80, and T1 is T1 sine of 65 equals 0. For the y-axis, I have T1 cosine 65 plus T2 cosine of 80. And we know the weight is 535 equals 0. Okay? Once again, doing this because we need to replace and actually get these variables in there. So now it comes kind of the coming part. I usually will do the x-axis for these kind of questions, mostly because the y-axis has a lot more variables in it. The x-axis is pretty clean on these, just these two things. So I usually just do this based off the x-axis, but it's total user's choice. So take this equation, rewrite it. So adding T1 sine over divide 65. So I have T1 is equal to T2 sine 80 divided by sine 65, which, remember, so math-wise, I could take these in any process I want. I'm going to do my sine of 80 divided by sine of 65. So that gives me T1 is equal to 1.087 T2. Okay, and now I'm going to substitute up there. Substitute. So this now is written as 1.087 T2 cosine 65 plus T2 cosine 80 equals 535, just adding the 535 over. So now let's simplify this bad boy down. So I'm going to take 1.0875 times cosine of 65 and get 0.46 T2 plus cosine of 80, 0.17 T2 equals 535. Okay, so let's just combine these two. And I get 0.63 T2 equals 535. Now, please remember, okay, when I do these, I am going the full numbers on these things. I know I'm rounding them on my paper, but I do use the exact numbers as long as I possibly can. So if your numbers are a little off, it is because of that reason. So try your best to always use exact numbers until the very end when we'll do the full rounding. So basically divide both sides by 0.63 number. So I get T2 is equal to 845.35 newtons. And then to get T1, we have this equation up here. So we now plug in. And I get T1 then ends up being this 8,800 number times 1.087, and I get 918.9 newtons. Okay, that's all she wrote.